morning. You had a chance to look at any of these recordings of our sessions?
I have not yet.
Okay, you know how to do it though? I showed you how
Yeah.
to do it? Okay. Yeah. I just always post them to that page on that website, so feel free to look at them or not. It's your choice.
Okay.
Okay. So let's see. What did we work on last night? Imaginary numbers?
Yeah.
We done with those?
For now.
Okay, good. That's really just about a half an hour's worth of material anyway.
Looks like the next thing in the book is completing the square.
Okay, good. Let me give you some. You got some problems for me, or you want me to give you some?
No, I don't. I didn't go to class today.
Can this be factored in a normal way?
No.
Because there's no factors of 10 that add to 6. Right? 2 and 5 don't add to 6. 10 and 1 don't add to 6. So I would normally have to use the quadratic formula to solve this. But the quadratic formula was actually come up with by completing the square. So the other method I have of solving this is to complete the square. Okay, now to complete the square, let's take our number and put it on the other side. So far I haven't changed anything. Now, let me give you the methodology for completing the square and then the understanding of why we do it this way. To complete the square, you take half of the coefficient of your x term, square it, and add it. So what's half of 6? 3 squared is 9. I just completed the square on the left side of the equation. However, since I added 9 to the left side of the equation, I got to add 9 to the right side of the equation to balance things out. Now, because I completed the square, I'm able to represent this quadratic on the left in the following manner. What's it equal to? -1. So now I have this, x plus 3 quantity squared. And that's the whole point in completing the squares, so that you can write it as an x minus h quantity squared. And you will always be able to do that if you complete the square by taking half of that coefficient and squaring it and adding it. That ensures that we're going to be able to write this thing as x plus 3 squared. Okay? You with me?
Yeah.
Okay, now how do I solve this?
Foil?
Take the square root of both sides. What's the square root of the left side?
X plus 3.
What's the square root of the right side?
I.
What's the next step?
Subtract 3.
I put it in front because I want this in the form a plus bi. So there's my solution to that equation, and I didn't have to use the quadratic formula to get it. In other words, I only had to complete the square.
Okay.
Okay, let's go over some more completing the squares. Do this one for me. What's the first step?
Add 11.
And not only add 11, but make room for completing the square. Notice I didn't put my equal sign right next to this, because I know I got to add something here. So what's the next step?
Divide 6 by 2 and
square it. So I'm going to add 9, and I'm going to add 9 over here. So now I have x squared plus 6x plus 9 equals 20. The next step is to represent the left side as an x plus or minus something quantity squared. What is that quantity going to be? It's always whatever half that was.
Okay.
Remember when we took half that, we got 3. That's what goes here. Plus 3 squared. Next step.
Square root.
So now I have x plus 3 equals plus or minus the square root of 20. I actually had a plus or minus I on the last one. I just forgot it.
Okay.
Whenever you solve an equation by taking the square root of both sides, make sure you put the plus or minus in there.
Okay.
Because in this problem it's key. Because this is a quadratic. I have 2 solutions. There's my solution. Square root of 20 is the same as 2 root 5. Okay. So, by completing the square and not having to use the quadratic formula, here's my 2 solutions. Plus 2 root 5 and minus 2 root 5. In other words, if I forgot to put that plus minus in there, I would have only gotten 1 solution. And there are definitely 2 solutions to this problem.
Okay.
Now, I would have gotten exactly the same solutions by using the quadratic formula. Just to show you, let's prove it. Here was my equation. Right here. Okay? Use the quadratic formula to solve that. Let me write out what it is. What is it? You remember?
Negative b over 2a.
No, that's the vertex.
Ah.
But that's close. That's half of it. There's the whole thing. What's negative b?
Negative b would be negative 6.
Plus or minus the square root of b squared is 36. Minus 4, what's a?
1.
What's c?
Negative 11.
All over 2. If I go to solve this, I get minus 6 plus or minus. This whole thing is 36 plus 44. Square root of 80. All over 2. Simplify this. Square root of 80 is 16 times 5. So I can replace the square root of 80 with 4 times root 5. Now separate it into 2 fractions. And I get minus 3 plus or minus 2 root 5. Same answer I got by completing the square. And, in fact, the quadratic formula is derived from completing the square. if I take a standard quadratic like this, and I go through the exact steps that I've gone through to complete the square, I get this for x. Now, there is a more difficult application of it. Let's go over. First step,
Add 11.
now the one thing you have to do before you complete the square is get rid of this coefficient by factoring it out. You can't complete the square unless you're looking at x squared plus something. So I'm going to factor out a 4 from the left side. Haven't changed anything yet. This equation's identical to that equation. With me?
Yeah.
Now, let's complete the square on the part that's inside the parentheses, because that's the only thing we can work with. So what do I have to put here?
4.
Now, what have I just done to the left side of the equation when I wrote plus 4 in there? How much have I added to the left side of the equation?
16.
So I got to add 16 to the right side of the equation. So now I have 4 times, and how can I represent this? X plus what squared?
4.
2. Remember, it's the half of that goes there. Equals 27. Now help me solve this. It's the first step to solve it. Remember, when you're solving equations, your whole goal is to isolate x. What do I need to do before I can isolate x?
Distribute 4.
No, that's going the wrong way. Trying to isolate x. That'll just expand it and give me the quadratic that I started with in the first place. How would I go about trying to end up with x equals something? What would be a good first step, starting from here?
Divide by 4.
There you go. So that's true. Now what's a good second step? Still trying to isolate x. Take the square root of both sides. So x plus 2 equals what?
Square root of 27 divided by 4.
Plus or minus. Okay. Now x is equal to what?
Plus or minus square root of 27 over 4 minus 2.
Let's put the minus 2 up front because it looks more like the quadratic format when we do that. And there's my answer, but I can make one last simplification. What is it? What can I do with this? That's the same as square root of 27 over square root of 4. What's square root of 4?
2.
In other words, when you have a radical and something inside of it, whenever you can pull out whole numbers, integers, you should do it. Now, what's the square root of 27 equal to?
Oh, no.
What's square root of 9?
3.
So it's 3 root 3. So that's what square root of 27 simplifies to, is 3 root 3. So my final answer is going to be minus 2 plus or minus 3 root 3 divided by 2. And again, I got it only by completing the square, not by doing the quadratic formula. Although it's the same answer I would have gotten by doing the quadratic formula. The key in this problem is always factoring out that coefficient of the x squared term. Let's do a hard one. We've got 9 minutes. I'm going to give you a hard one to do. First step,
Add 14.
next step,
Factor out 4.
leaving
X squared plus 3/4 x.
still no change. Now what?
Divide by 4.
No, not yet. We got to complete the square. Remember, once we get it in this format, our whole goal is to complete the square so that I can represent this as x plus something squared. So how do I complete the square again? What do I do with this coefficient?
Divide it in half.
What's 3/4 divided by 2?
I don't know.
Put a 1 under the 2, flip that and multiply. You get 3/8.
Okay.
Okay, square 3/8. 9/64. You with me?
Yeah.
What did I just add to the left side of the equation that I have to counterbalance by adding it to the right side?
9/64.
Times 4. You see, when I wrote in 9/64, I didn't add 9/64 to the left side of the equation. I added 9/64 times this 4. So I really added 36/64. So I have to add 36/64 to the right side of the equation. Now I've got 4. How can I represent this? X plus what?
3/4.
3/8.
3/8.
After you've divided that by 2, that's the number that's always going to go there. In other words, I still haven't changed anything. I still have the original equation I started with. I just have something that's a lot easier to solve now. Now I divide both sides by 4, take the square root of both sides, and then subtract 3/8 from both sides. I don't want to go through all that math because I made these numbers up and I ended up with a very complicated fraction there. It's not easily divided by 4. Doesn't matter as long as you know how to do it.
Okay.
This is about as hard as it gets, where we had a coefficient in front of the x term that we had to factor out, and it left a fraction as my coefficient in front of the x term. Well, once you get a fraction here, it becomes a lot more complicated because now you got to divide that by 2 and square it, so you get an even more complicated fraction. And then you got to multiply that by 4 and add it to the other side to balance it.
Okay.
All right. So let me just cover one other thing in the 5 minutes that we have. Let's say that they say to you, put this in vertex format. Excuse me. There's our equation. Y equals x squared minus x minus 11. And they say put it in standard format, which is vertex format. What's vertex format for a quadratic?
I don't know.
Right here. The advantage of having a quadratic in vertex format is you don't have to go through minus b over 2a. The vertex is hk. It gives you the vertex instantly. So if you can take this quadratic and convert it to vertex format, we can answer a whole lot of questions about projectile motion, maximums, everything. So it's very valuable to be able to put it into this format. Well, notice what we're looking at there. Somebody has completed the square. So let's solve this. I'm going to do this. I'm going to separate out the x squared and x. I'm going to put my minus 11 way over here on the right side, but leave it on the right side. Now I'm going to complete the square here. How do I complete the square?
-1 divided by 2.
So that's minus 1/2 squared
Minus a quarter.
plus a quarter.
Plus a quarter.
When you're completing the square, this is always a plus. Because when you take minus 1 and divide it by 2, you get minus 1/2, but when you square that, you get plus 1/4. So this will never have a negative sign on it when you're completing the square. Now, this is a little different than the problems we did earlier because my number was always on the other side of the equation. So to balance out, I did the same thing to the other side of the equation. Well, this one I want to leave everything on the right side because I'm trying to get to that format there. So I'm not going to move my 11 anywhere, but I just added 1/4 to the equation. So what do I have to do to the same side of the equation to balance?
Subtract a quarter?
Minus a quarter, exactly. In other words, I didn't do anything. I didn't change anything. I added a quarter and I subtracted a quarter. The difference is now it's much easier. I can put it in vertex format by saying x minus what? Quantity squared?
An 8?
What was this after we took half of it?
1/2.
There's my formula. I got it in vertex format. What's the vertex?
Uh, 1/2, comma 11 1/4.
Close. 1/2 is right because it's x minus h, but it's plus k. So the y coordinate is minus 11 and a quarter.
Okay.
Okay. So if we had the equation of motion or whatever, and we want to know what that point is, that's 1/2 comma minus 11 and a quarter. I plotted it wrong. It's going to be underneath the x-axis, but that's about all you need to know for completing the square. I've done it in two situations. One where I had to balance it out by adding to the other side of the equation, and one where I had to balance it out by adding to the same side of the equation.
Okay.
The only difference is the sign you put on it. Just always make sure that you can never change the equation. You can manipulate it. I mean, you can change it, but you can't make it different. Whatever you start with, you got to end up with. All right. That's a good half-hour session on completing the square. You could probably stand to do some practice with it. In other words, most of the half-hour session tonight was me talking, telling you how to do it. Mm-hmm. The real key for you to learn it is going to be doing some problems on your own. And unfortunately, in a half-hour session, it's hard to do it all. It's hard for me to show you all of the techniques needed for completing the square and then give you a chance to do problems. So maybe we can do that tomorrow night or whatever. If you got more topics you want to cover tomorrow night, that's fine also. But don't forget that piece. In other words, tutoring, we don't want this to be the same as you going into class and listening to your teacher lecture or tell you how to do stuff. Tutoring is fundamentally different. The fundamentally different part is that I want you to be doing some problems. That's the way you really learn, is by you doing problems. All right? I will talk to you tomorrow night at 8, Silas.
Okay.
All right? Have a good evening.
You too.
Bye-bye.